Now, in the last one, we talked about graphing, systems of equations, and the solution to a system is the point of intersection where the lines cross. So all we did in the last one was we graphed our lines, right? We had to rearrange some of the equations, in the slope-intercept form. We put our lines on paper, and then we saw where the lines intersected. And that point where they crossed was the final answer, was the actual solution. Here, we're going to solve the system of equations, but without graphing. We're going to solve it through different means, different methods. So this one's going to cover the substitution method, then the elimination method. And then if we have time, we'll also do the inequalities at the bottom. So substitution method. Substitution method goes like this. Essentially, if you have an equation, let's go back to our blue. If you have an equation, like this one here, this says y equals 6x minus 11. What this is saying is that y is equal to 6x minus 11. Think of it like as if y was equal to just let's pick a number like 10, right? If I told you that y was equal to this thing, like 10, right, then you would simply plug 10 in where y is, right? You would have the next equation would be negative 2x minus 3 times 10, right? Because that's what the y was equal to negative 7, and you would go about solving it. Catch is, though, we're not, y is not equal to 10. Y is equal to an expression, but it doesn't change that fact that we can just take this expression and still substitute it in where the y was. So rather than 10, it'll be 6x minus 11. Now we put in those parentheses. Now let me spread that out a little bit so it's easier to write. Let me actually use a different color as well. So let me use red for my substitution, right? 6x minus 11 equals negative 7. So what used to be, right, negative 2x minus 3 times y equal to negative 7 is now negative 2x minus 3 times 6x minus 11 is equal to negative 7 because y is equal to 6x minus 11. So now that I've plugged it in, that's all the substitution method is. The rest of this problem is just solving the equation. And we did this back on the review sheet part 1. We were just solving equations on review sheet part 1. So here we're just solving equations. I have finished my substitution method. That is the substitution method. The rest of this is just solving the equation like I said, like we did on part 1. So the first thing we're going to have to do is distribute. We're going to have to multiply this negative 3. Keep in mind it is a minus sign here, so that negative has to go with it. Negative 3 has to get distributed to the 6x and the minus 11 because that's what y was, and we're multiplying it to negative 3. So I'm just going to bring this negative 2x down. All right, and when I multiply, that'll be negative 18x because negative 3 times 6x makes negative 18x. And then negative 3 times negative 11 makes a positive, because 2 negatives make a positive, 33, right? And then we have equals negative 7. So let's combine a few like terms. So we've got these x terms here, negative 2x minus 18x. That combines negative 2 minus 18 is negative 20. Some simple algebra, but very easy to get wrong if you mess up with your negatives. But yes, that does make negative 20x plus 33 equal to negative 7. Again, just regular problem solving, right? Subtract 33. We end up having negative 20x equal to negative 40. And so when we divide by negative 20, we have our answer of x is equal to a positive 2. Now, there's also another problem here, right? Is that a solution to a system is a point, as we've mentioned in the graphing ones, right? It's a point, an xy ordered pair. So our solution has to be a point as well. And I'm going to go ahead and preface this and put these here for these later. So the x value here was 2. We just established that the x value was 2, but I still need the y value. Now, the y value is a little easier to find. If I want to find the y value, then I'm going to just take the 2 and plug it into the equation. So for my y value, let me go back to my colors. For my y value, I'll just plug it into one of these equations. It doesn't matter if I plug the 2 in for this x in the top equation or if I plug it into the x in the bottom equation. It doesn't matter. But I find the first equation will be a little easier to plug into. So I'm going to use that one. So y equals 6 times 2. I'm going to put 2 there in a second. Just going to use a different color. 6 times 2 minus 11, because that's what x was, right? And then when I evaluate this, when I solve this, I am going to have my y, right? So this will be y equal to, this becomes 12 minus 11. And so our answer is y is equal to 1. So we have x is equal to 2, y is equal to 1, and we have our answer there. All right, so I'm going to repeat this process for number 6 and number 7. So I'm just going to move this over, and I'm going to do the next one just to the right of this problem. All right, so we have a little bit of a different story in the second one because we don't already have an equation where I have y equals this or x equals this, right? I don't have any information that I can actually substitute in. So what I'm going to need to do is I'm going to need to take one of these equations and try and get the y by itself or the x by itself. Now looking at these, I see that this y here is positive and it's all alone, essentially, right? So this y here in this equation would be the easiest to try and isolate because it's already positive and it doesn't have a coefficient, it's just a regular y. So that's what I'm going to do. I'm going to try and get this essentially into y equals mx plus b form, something like we saw in number 5. So that's my first step. So I have 4x plus y equal to 6. So a simple thing, simple process. We're going to just subtract the 4x to try and move it over. And we end up having y equal to negative 4x plus 6. Okay, hopefully you're good at that by now because we've been doing it a lot in the first part of our review and on the last part where we were doing the graphs before this. Okay, so now I have information that's useful to me. I know what y is equal to. Now, it's not a number, but I know that y is equal to this expression. So I'm going to use that, and I'm going to substitute it into its brother equation, right? So the negative 5x minus y equals 21. So I'm going to plug that negative 4x plus 6 in where that y goes. So when I write this equation out, negative 5x minus y, I'm going to put the y in a different color, equal to 21. I put the y here in red so it stands out, right? I am plugging this in for that y. So when I plug it in, it's going to be negative 5x minus, put this in parentheses, my y, which is equal to negative 4x plus 6. Yes, they are in the parentheses there because it's a negative y, and thus it's a negative 4x plus 6. Don't forget equals 221. So that's my substitution. That is all the substitution is. I am done with my substitution. At this point, again, it's just algebra. It's just trying to solve the equation. So we're going to start by, like we did last time, distributing. So we're going to keep the negative 5x here. Be very mindful that the negative out front, this is a negative 1. If you want to rewrite it as negative 1, you can, okay? But it is a negative 1. So we're going to distribute that negative to both these. So negative 1 times negative 4x makes a positive 4x. And a negative, don't forget, it goes to the 6 as well. Negative 1 times 6 makes a negative 6. And then equals 21. All right, we have a couple like terms we can combine. The x terms we can combine. Negative 5x plus 4x is just negative 1x. Bring down this minus 6. Bring down this 21. And we'll continue solving this. We'll add the 6 to both sides. We'll have a negative x equal to 27. And then, of course, divide by this negative 1. And we have x is equal to a negative 27. So we've got our x value, negative 27. Just want to double check, make sure everything looks good. Oh, wait, no, I did that right. Okay, I thought I messed up something there. I think I'm good. All right, but we'll find out in the end here if I ever did make mistakes. So x is equal to negative 27. So now we're going to plug in that negative 27 where that x is, and we're going to solve for y. So I'm going to actually go back up here and use the equation that I've made earlier to plug my x in. I think that's going to be the most simple one to plug into, since the y in that equation is already semi by itself. I just have to put the x in here and evaluate for that number. So let's do that. So our equation, let me use again red. Our equation, y is equal to negative 4x plus 6, but I'm going to plug in that negative 27 here, because x was equal to negative 27. So let's do the math. This is going to become y is equal to negative 4 times negative 27, which I don't know off the top of my head. 108, so positive 108 plus 6, which means that y is equal to 114. All right, now I'm going to double check that this works. I'm just going to, because it seems like really large numbers, I want to see if this actually fits in the other equation as well. So the other equation is negative 5 times x. So let's try this out. Negative 5 times negative 27. So negative 5 times negative 27 is 135. And then subtract y, subtract 114, and we get 21. So it does work. So that is the correct answer. Very large numbers. I can see if you were doing it and you felt like you were doing it wrong. I almost felt like I was doing it wrong for a second there. But it does fit. Because I plugged the x and y into the other equation, and it does work. Which is good. Good to know. We have one more problem to do. And it's very similar to this last one, but it's a little bit different too. So I'm going to just bar this off. I'm actually going to bar that off. We're going to do it right there in that space. So our equation, again, what we have is we have this issue where we don't have a y equals anything or an x equals anything. But what I do notice out of these two equations is that this x here, again, is kind of all by itself, right? It's a positive x. And there's no coefficient with it. It's just a regular x. Every other variable here has a coefficient. Like that one's got the negative 7, this y has a negative 2, and this y also has a negative 2. Which means if I were to try and isolate those variables, try to get them by itself, I'm going to have to divide these numbers off of it if I wanted to do it. And that dividing can create fractions and make the problem difficult for us. But because this x is by itself, it won't need any dividing. All we would have to do to get that x by itself is simply, where's my eraser? Is my eraser not going to work? There it goes. Is simply move the negative 2y. So that's what I'm going to do. I'm going to do that first. It's kind of like how we isolated the y in number 6. We're going to do that same thing here, but with the x, and that's okay. It doesn't always have to be y. So the equation was x minus 2y equal to 11. So pretty simple. To get this x by itself, I'm just going to add the 2y to the other side. Add 2y. So we end up saying, this says x is equal to 2y plus 11. A little unconventional from what we're normally doing because we normally have y equals, but that's okay. We have x equals here. So it's going to still follow the same pattern, just a little bit opposite, because now we're actually going to plug in for x. So let's take the other equation. The other equation was, negative 7x minus 2y equals negative 13. So negative 7x, I'm going to put the x in red in a second here, actually. Minus 2y equals negative 13. Let me just again double check that that's correct. All right. It was negative 7x. Let me put the x here. I'm going to put it in red so it kind of stands out, right? So x is equal to 2y plus 11. So we're actually going to plug that in where the x is. So when I write this equation, I'm going to have negative 7 and then times x, but x is not x anymore. X is going to be 2y plus 11. 2y plus 11. Oh, I accidentally wrote x there when I should have wrote y, right? That was negative 2y. You guys might have noticed that. I didn't catch that before. Let me put that back. Negative 2y. There we go. All right. Then continue writing this equation. Minus 2y equals negative 13. So all I've done here is I've replaced the x with the 2y plus 11 because, as we established, x is equal to 2y plus 11. So I can make that replacement. And now I've done the substitution. Substitution is over. All I have left to do is just the algebra. So we're going to start by distributing this negative 7. Negative 7 times 2y makes negative 14y. Negative 7 times 11 is going to be negative 77. Let's bring down everything else. Bring down this minus 2y, and then equals negative 13. Okay. So we've got a lot going on here, but we got these two y terms. We can combine those. Negative 14, negative 2 is going to make a negative 16y. Bring down this minus 77 equals to negative 13. All right, so we're going to add this 77. We're going to have negative 16y equal to 77 minus 13, which is 64. And then, of course, divide by negative 16. So we end up with y equal to a negative 4. So y is equal to negative 4. Now it's actually, the negative 4 is actually going to be blue here because I did the kind of reverse things here because I actually plugged in for x instead of plugging in for y. But y is equal to negative 4. And now we simply need to find this x value. So I'm going to use the equation from earlier because x is equal to 2y plus 11. I'm actually going to use that. Oops, didn't want to hit that. Okay, yeah, it's fine. All right. So remember, x is equal to 2y plus 11. I'm actually going to put the y in here in blue. 2y plus 11, but y is equal to negative 4, remember? So we're going to plug in negative 4. So this means x is equal to 2 times negative 4, but I'm going to put that in blue here in a minute. Right, 2 times negative 4 plus 11. So when I solve this, 2 times negative 4 is negative 8. So this is x equal to negative 8 plus 11, which simplifies into 3. So x is equal to 3. We're going to put that in, and we have our answer. There's our solution. So substitution method is really just one part of it. Okay, so the substitution method, I'll use this highlighter real quick. The substitution method is really just this. You have the regular equation, and then you have the part where you plugged in. That's the substitution method. Everything else after that is just regular algebra, okay? So again, substitution method in here is you had your equation, and you plugged in, right? That's substitution. That's all it is, right? Just that replacement. And same thing here. You had your regular equation, and then you plugged in to that equation. You've made your substitute. That's substitution. Everything, the part that's highlighted is substitution. Everything else around it was just regular algebra. Okay, regular algebra stuff we've been doing all year, and you practiced in part 1. Okay, so let's talk about the elimination method. Elimination method is faster, usually, if it's set up properly. And it takes a little less algebra to solve in most cases, but we'll see. All right. So what the point of the elimination method is, our goal is we're going to have two equations. We're going to add the equations together, but when we do so, one of the variables has to cancel out and be eliminated, right? It's called elimination for that reason. So look at these two equations. Now, everything, first off, you want to make sure that everything is lined up, right? X's are lined up, our Y's are lined up, equal signs are lined up, and these constants here at the end are lined up. The reason it has to be lined up is because we're going to essentially just add these together. But you don't want to add them together unless a variable cancels out. And this problem's already set up very nicely, where in this case, the X's are going to cancel out. Because this negative 4x plus this 4x will actually be 0x, meaning that the x's will be eliminated. And then we'll have the rest of the equation to solve for y. So essentially, that is all the elimination method is. It's just going to be adding these equations together, but it's only going to work if you can eliminate or cancel out one of those variables. So we can add these together because the x's are going to cancel. So negative 4x plus 4x, we know that this is 0x, meaning that x's are eliminated. And then when I add these y's together, I have negative 2y plus 8y. So negative 2 plus 8 is 6. So that's going to be 6y equals, and then I'm adding these. So negative 12 plus negative 24, just, negative 12 minus 24, same thing. Is this actually negative 36? So now we just have this equation. We have 6y equals negative 36. And all we're going to do is solve for y. Very simple, just divide by 6. And we've now solved for y. Y is equal to negative 6. So when I'm writing my answer, remember my answer is going to be an ordered pair. It's going to be a point. So it's going to be an x, y point. I'm going to do that for these other ones as well. Right, this is where my answers are going to be. I already know that y is equal to negative 6. So right there. Now, how do I find x? Well, you find x by doing the same thing that you did in the substitution, which is plug in your y. So it doesn't matter which equation you pick to plug into, whether the first one or the second one. I'll pick the second one just because it's got positive numbers in it. But the second equation was 4x plus 8y equals negative 24. Now, I already know that y was negative 6. So I'm going to plug in that negative 6. So my equation is going to be 4x plus 8 times negative 6 equal to negative 24. I'm just going to put the negative 6 here in blue so it kind of stands out. Right? So that's all I'm doing. And I'm just going to solve this equation now for x. So this is going to be 4x. This will be minus 48 equal to negative 24. So we'll add 48. And this means that we'll have 4x equal to positive 24. And then when I divide by 4, I end up having x equal to 6. So that's actually more work than the elimination method itself, right? The elimination method was just this right here. That was all the math we had to do. Finding the other variable actually took a little longer, plugging in the number and then solving. But we got our answer nonetheless. So x was positive 6, y was negative 6, and we have our solution. Now, next problem is a little bit different. Because if I were to just go ahead and add these equations together, I would have 15x, meaning the x's aren't eliminated, right? Because I have 15 of them. If I added these y's together, I would have a negative 6y. But again, that's not a 0y. That's not eliminated. So there has to be some work we do ahead of time. We can't add these equations together because the x's won't be eliminated and neither will the y's. So what I'm going to do is try and change this up a bit and try and cancel something out. So there's a couple different options. Let's say I wanted to cancel these x's out. These are possible to cancel out because if I were to multiply the top equation by negative 2. Now you're wondering, where did I come up with this negative 2? I came up with this negative 2 because I can see in the problem that if I were to have a negative 10x, that would cancel with this positive 10x. So I have to be able to kind of see this ahead of time. I have to see, hey, you know what? 5 and 10, they're kind of similar, right? 5 is just half of 10. So if I was able to double the 5 and make it 10, then I can maybe make these cancel out. And I chose a negative 2 because it will, when I multiply it with 5, it'll become negative 10, right? Negative 2 times 5 is going to make negative 10, and negative 10 then cancels with positive 10. So that's what I'm going to do here. So before I actually add these equations together, I'm going to first multiply that top equation by a negative 2. So when I do that, remember all parts of this get multiplied. So this equation then becomes negative 10x because negative 2 times 5x becomes negative 10x. Negative 2 times y will become a negative 2y. And then negative 2 times 9 will become a negative 18. So that's my top equation, same exact equation, but everything was multiplied by negative 2. The second equation, I'm going to leave exactly the way it was. I won't change it, multiply it, or do any of that. We'll just leave it as 10x minus 7y equal to negative 18. And the reason is because now, if I were to add these equations together, I would cancel out my x's. Oh, hold on a second. I just moved my paper. Hold on. Let me put this back where it was. All right. Ooh. Yeah, that looks like it. All right. Sorry. Sometimes I hit the thing and it moves. Okay. So yes, now I can actually add the equations together and these x's will cancel out. Negative 10x plus 10x becomes 0x. So therefore the x's are eliminated, which is good. X's are no longer existing. Now I just combine everything else, right? So this will become a negative 9y and this will become a negative 36. So when I solve for y, I divide by negative 9 and I have y equal to positive 4. So my y is equal to positive 4. That's good to know. And now we just, again, plug this in to find x. So I'll plug it into the original top equation, which is 5x plus y equals 9. So the original top equation, 5x plus y equals 9. Let me write that down. 5x plus y equals 9. Again, I'm going to just, so for it stands out, I'm going to put the y in as blue. Right, so I'm going to plug in 4 for that y and then solve for x. So 5x plus 4 is equal to 9. Let me put the 4 in. Right, I'm just plugging in the 4 for the y. So when I solve this equation, I'll subtract 4 first, minus 4. We have 5x equal to 5. And then, of course, dividing by 5, we end up with x equal to 1. So x is 1. We already knew y was 4, and we have our final answer. Now, number 10 is a little more challenging because, again, we have that same thing in number 9 where, these aren't lined up to cancel out, right? If I were to add these together, 5 plus 3 makes 8. Nothing's eliminated, right? 4 plus 6 makes 10. That's not going to work because I need one of these variables to cancel out. I need one of these variables to disappear. So we've been making the x's disappear in the past one, so let's make the y disappear here. But you can do it either way. So let's try to actually cancel out these y's. Now, in order to do that, I need to find some kind of balance between them. One of them has to be positive and the other has to be negative. And what I'm looking for are common factors of 4 and 6. Now, one common factor they both have is 12, right? 4 times 3 can make 12, and 6 times 2 can make 12, right? So let's try to make these y's, instead of 4y and 6y, let's try to make them 12y. Now, one of them has to be negative, though, right? So they're both positive, so let's make one of these negative. So what I'm going to do is I'm going to multiply this top equation by negative 3, because that negative 3 times this 4 will turn this into a negative 12. And I'll multiply the bottom equation by a positive 2, because a positive 2 times that 6 will make a positive 12. And at that point, we'll then have a negative 12y and a positive 12y that can cancel out. So again, I'm kind of trying to foresee the future here. I'm trying to come up with a plan of how to force these to be eliminated. And now I just have to do my execution. So I chose negative 3 and 2 because negative 3 is going to turn this into negative 12. And then the 2 on the bottom is going to turn this into a positive 12. And then the negative 12, positive 12 will cancel each other out. But don't forget, you have to do this with all 3 parts, right? It's just not just one term. So the top equation, when I multiply everything by negative 3, becomes negative 15x minus 12y equal to, what's 14 times 3? Is that 42? I think it's 42. Yeah, it's a negative 3 times a negative 14, so it'd be a positive 42. If I multiply the second equation by 2, then that's going to become a 6x. It's going to become a positive 12y, and it's going to turn into a positive 12 at the end as well. So now I have a new set of equations that are based off of the original set, but now if we were to add these equations together, we're going to get the y's to cancel each other out, thus eliminating our y's, which is good. Negative 12y plus 12y becomes 0y, and therefore the y is now eliminated. So let's solve the rest of this. So negative 15x plus 6x is negative 9x. And then 42 plus 12 makes 54. So divide by negative 9 to cancel that out. And we end up having x equal to negative 6. So x is negative 6. And now we just plug this into the equation and try and find y. So it doesn't matter which equation you plug it into. I'm going to use the second equation, the 3x plus 6y equals 6. I'm going to use that, and I'm going to plug -6 in for that x, since I know x is equal to -6. So 3x plus 6y equals 6. All right, so 3x plus 6y equals 6. Now, again, use a different color so it stands out. 3 times x plus 6y equals 6. So we're going to plug in the -6 here. So it's going to be 3 times -6 plus 6y equals 6. And okay, let's move this over here real quick to try to evaluate this. So that's going to become a -18 plus 6y equals 6. I'm going to add 18. This is going to be 6y equal to 24. And then when I divide by 6, I end up with y is equal to 4. So I have my answer right now. Okay. So it's definitely a little bit of work. Let me put some barriers around here. So if you're reading this later, you can kind of make sense of what we did. We put black lines. So this separates that problem. This separates that problem. Okay. There we go. Kind of sloppy, I get it, but it's fine. It's fine. All right, I know we're running a little long here, but let's go ahead and do the system of inequalities next, so I don't have to make another separate video for this. Oh, I gotta stretch, go stretch, go stretch. All right, here we go. All right, so this is basically the same thing as solving regular equations, but with just the added benefit of shading. So let's do blue and red again. So blue. So this first equation, let's put this in blue. Now it's already in mx plus b form, slope-intercept form, so it's easy to graph, right? Our y-intercept is -2, so we're on the y-axis, -2, and our slope is a negative, meaning that our slope is -1 or -1/1, right? So this means going down 1 and then right 1. So we're going to go down 1, right 1, and that puts us here for our next point, right? Down 1, right 1 puts us here for the next point, there. And then we can also go backwards and go up 1, left 1. That, again, puts us there. Just trace out the rest of this line. Up 1, right 1, and so on. Now, there's two things to consider here. It's the line itself and the shading. So because our inequality is got the less than or equal to part, this is going to be a solid line. So remember these things, okay? Less than or equal to or greater than or equal to is going to be a solid line, whereas regular less than, regular greater than would be a dotted line. Okay, so since this one's got the line underneath it, right, it's or equal to, then it's going to be a solid line. So we're going to do a solid line through here. And now we need the shade. This is the second part of it. We need the shade. I'm going to use shade in blue, of course, since we got a blue line. Now, y is less than, so y is less than means y is below. So we're going to shade below our line. So we're going to shade this portion here. There we go. Now we have to graph the other equation. So I'm going to do the other equation. I'm going to do this in red. So again, it's already in slope-intercept form, which is nice. We have our y-intercept is +2. And then our slope is -5, also -5/1, right? So down 5 and then right 1. So if we go down 5, go down 1, 2, 3, 4, 5, and then right 1. That puts our point right here, overlapping that one. And I don't actually have any room to do anymore. So that's going to be where my line goes. And it's going to be a solid line for the same reason as the last problem. Solid line. We're going to do a solid line right through it. Best we can. It's just, can't make it any straighter than that, guys. It's perfect. All right, now we need the shade. So let me use my highlighter. Okay, red's going to be too bright. So let's use like a pink. Okay, so we're shading y greater than. Okay, now it's very tough to tell because of how slanted this is. It's more like a left or right. But because it's leaning towards the left a little bit, the above hand side is going to be over here. And if you're wondering how you can tell, just take any point and go up, because greater than means above. And if you go above that point, you'll see which side of the line you preside on. So it's definitely going to be this side of the line. So we're going to shade in this side of the line. All right, there we go. That's our answer. Technically speaking, the overlapped region where these two shaded regions cross is our solution set. So it's going to be infinitely many answers because there's infinitely many points in that section. Imagine if you were able to continue this on, every point in that section would still count as a solution. So it would go on forever. But yeah, that overlapped region is the definitely the point of interest where our solutions would be. All right, let's do number 12. Again, this is slope-intercept form, which is very nice for us, very easy to use. So the top equation, our y-intercept is -2, and our slope is -5/2. So think -5/2, so think down 5 and right 2. Unfortunately, I can't go down 5 and right 2 because there's not enough room. So we'll go backwards. We'll go up and left. So we'll go up 5, 1, 2, 3, 4, 5, and left 2. So that puts us right here. So that's where our line is. This is also going to be another solid line because of the less than or equal to sign. And we're going to shade below because it's y is less than. So below is going to be this side of the line. So we're going to shade over here. There we go. Nailed it. Perfect. All right, good stuff. All right, so now let's do the other inequality. So the other inequality, we have a y-intercept of +2 and a slope of -1/2. So -1/+2, think of -1/2 like that. So think down 1 and then right 2. So down 1, right 2 puts us right here. And do that again, down 1, right 2 puts us right here. And if we go backwards, up 1, left 2, up 1, left 2, then we get that line. Now this one's going to be a dotted line because it's just a regular less than sign, not a less than or equal to. So dotted line this here. Okay. And then we're going to shade below the line because it's y is less than. So below the line will be pretty obvious. It's going to be this part of the line. All right, and again, our answer is going to be the overlapped region, technically speaking. So our answer base is going to be, all of this stuff. All right, number 13. Number 13 is a little more work because it's not in slope-intercept form. So let's take this equation. Let's put it in slope-intercept form. So 4x plus y is less than 2. This one's pretty straightforward. You just have to subtract the 4x to move it over here. And now we have y is less than -4x plus 2. So now we can actually graph that. We know the y-intercept is +2, and our slope is -4 or -4/1, meaning, let me write it down, -4/1, meaning down 4 and right 1. So we're going to go down 4, 1, 2, 3, 4, and then right 1 puts our point right here. So our line there, and it's going to be a dotted line, again, because it's got the regular less than sign. So a dotted line. And let's see, where are we shading? We're shading less than, y is less than, so we're going to shade below the line. So remember, take a point and go down, because below is down, and that can show you what side you're going to shade. So you're going to shade this side. Now the second inequality is just a flat line. This inequality here, y is greater than -2, has a y-intercept of -2, but it has a no slope. So it's not going up any or down any, it's just going to stay at -2 the whole time. So you're going to have a horizontal line straight through -2, but it's going to be a dotted line because it's just a regular greater than sign. So just a dotted line through -2. It is greater than, so we are shading above this line. Pretty straightforward. Above is going to be the top part, so we're shading in right here. And so our answer is technically, again, that overlapped area, the overlapped area of all of this stuff. And we have one more. So this one's going to take a little bit of work to put in slope-intercept form again, but we've practiced that plenty, right? So if we take 3x plus 2y greater than or equal to -2, we solve this. So subtract 3x first. Remember, you always move the x term first. We have 2y is greater than or equal to -3x minus 2. and then we'll divide by 2. So you always move the x term first, then divide the number on y. So we have y is greater than or equal to negative 3 over 2x, and then negative 2 over 2 simplifies to just negative 1. So I know my y-intercept is at negative 1, and I know my slope is negative 3 over 2, meaning that it'll go down 3 and then right 2. I feel like all these slopes are negative 2, by the way. It's crazy. Down 3 and right 2 puts us right here. And so let's go backwards. Let's go up 3, left 2, fill it all out. And this will be a solid line. Here we go. Y is greater than negative 3 over 2x minus 1. Y is greater than or equal to. So greater than is going to be above. So we're going to shade above this line. It's going to be this part of the line. All the area above it. There we go. Now we just got one more line to graph. So we have x plus 2y is less than or equal to 2. So we're going to have to solve this for y as well. So we're going to move the x term first. So we'll subtract x to move that. We'll have 2y less than or equal to negative x plus 2. Divide by 2. Same steps as before. Move the x term and then divide the number on y. So we have y is less than or equal to negative 1 over 2x, because that's a negative x, is negative 1. Plus 2 over 2, which simplifies to just 1. Don't forget, 2 divided by 2 is not 0. 2 divided by 2 is 1. Be very mindful of that. So the y-intercept is at positive 1. And then our slope is negative 1 over 2. So down 1 and right 2. So if we go down 1 and right 2, that'll put us here and here. And we can go backwards, up 1, left 2, puts us here, here. This is another solid line because of the less than or equal to part. And because y is less than or equal to, the less than means that we're going to shade below the line. So that's going to be down here. All of this region below the red line. And of course, you see where the overlap area is. The overlapped area is technically where the solutions are. So any point in that overlapped region would be our answers. That's it. I know it was a long video, but it covered like a lot of different things. So I'll see you guys later. We'll see you in part 3.